Good morning, class. It's Miss Brasfield. Well, today I'm going to be reading from the book Mountains. We're going to start on page 9 and try to get to 18 in this reading. Let's get started. Mountain ranges do not arise just any place. Most are formed when plates, giant pieces of the Earth's crust, push and pull against each other. The United States, Canada, Mexico, and part of the North Atlantic Ocean are on the North American plates. The Rockies and the Coast Ranges of the western United States and Canada were formed where the North American plate pushed against the Pacific plate. The Mid-Atlantic Ridge, a 12,000-mile-long underwater mountain chain that stretches the length of the Atlantic Ocean, was formed where the North American plate pulled away from the Eurasian plate and the African plate. The islands of Iceland and Surtsey are actually the tops of volcanic mountain peaks reaching above the surface of the ocean, which covers most of the Mid-Atlantic Ridge. Okay. Let's see here. There we go. Rocks are hard, but with time and pressure, they can bend or fold. Hold a large piece of paper at either end and slowly push toward the middle. The pressure of your hands causes the paper to buckle and fold. In the Earth's crust, pressure pushes sideways against the rocks. The rocks twist and bend, producing great folded mountain chains. It takes many thousands of years to bring about changes in the rocks of the Earth's crust. The Alps are folded mountains that form as the Eurasian plate pushed against the African plate. Most of the great mountain chains on Earth including the Himalayas, the Andes, the Rockies, and the Appalachians, are folded mountains. When the bare mountainside is exposed, you can see the folds in the layers of rocks called strata, such as these folded peaks in the Rocky Mountains in Montana. Still, other mountains are formed by the eruption of volcanoes. During a volcanic eruption, magma squeezes up through cracks in the Earth's crust and explodes out as lava and ash. When huge amounts of hardening lava and cinders pile up around the vent or opening, they form a volcanic mountain, such as Mount Hood in Oregon, top right. The Hawaiian Islands are the tops of volcanic mountains that rise 30,000 feet from the depths of the ocean, making them even taller than Everest if you measure from the ocean bottom. This aerial view of Hawaii, bottom right, shows some of its volcanic cinder cones. Dome mountains are formed by the same kind of molten rock that forms volcanic mountains, but dome mountains do not act or even look like volcanoes. They too result from a welling up of magma from deep within the earth through a crack in the Earth's crust. However, in dome mountains, the magma does not come to the surface. Instead, the molten rock pushes the ground up into a round or dome-shaped bulge, and the magma gradually hardens into rock. When the softer rocks above are worn away, the great dome of underlying rock is revealed. The Adirondacks of New York and the Black Hills of South Dakota are dome mountains. Yosemite's Half Dome, right, is a dome mountain that was cracked in half when sheets of granite fell off one side and were carried away by a glacier thousands of years ago. As soon as mountains rise, they begin to be worn down steadily and slowly by the forces of erosion, wind, rain, moving water and ice, as well as temperature and chemical changes. Some kinds of rocks, such as limestone, dissolve in water, but most water erosion on mountains is caused by streams and rivers that plunge down the steep sides, lifting up rocks and pushing them along to rub and scrape against other rocks. In cold climates, slowly moving rivers of ice called glaciers are carved. Can't see the rest of that. Rocks expand daily in the heat of the sun and then contract again during the cold nights. These constant temperature changes begin to crack the rock. Water gets into the tiny cracks, freezes at night, expands, and